Hello and good afternoon, everyone. I hope I'm audible to all of you. Again, I welcome you to yet another webinar presented by Omics Nexus, and it is from Zero to Repo, Basics of GitHub for Beginners. So yeah, this is Haseeb Manzoor, and I'll be the moderator for today's session. And I'll start with the introduction of Omics Nexus. So in Omics Nexus, what we believe, we are trying to make the bioinformatics accessible for everyone. As in, we also define what it means to be a scientific solution partner, as we have expertise in bioinformatics, NGS data analysis, multi-omics, AI-based biomarker discovery, pipeline development, different meta-analysis and systematic reviews, scientific writing, and healthcare business development to deliver the data-driven impact. So, as you also have got the idea that what we offer, we deliver advanced bioinformatics and artificial intelligence solutions that drive smarter, faster healthcare decisions. We provide services including bioinformatics analysis, AI and machine learning, different automation and pipeline development, and statistics and data analysis. We also help in scientific writings, content writings, and drafts and illustrations. Also, we provide consultancy services in terms of research development or whatever the scientific problem you have. And last but not the least, we are also providing some trainings and workshops to all the people, regardless whatever their background is, even if they are bioinformatician or they belong to any kind of life sciences fields. We offer them trainings and workshops so they can, pursue their career in bioinformatics. So what sets Omics Nexus apart? As we come with a background of multidisciplinary expertise, all of the team, all of the people who are under the umbrella of Omics Nexus, they have a settled foundation in bioinformatics. We provide tailored end-to-end solutions. We help you from the very start until the very end in order to develop any kind of project and help in any kind of research work. Also, our consultations are always free. We also offer free consultations to all those people who are having any kind of trouble in their research. And we offer some free sessions, and definitely if it is followed by some paid sessions as well. Moving forward, we have proven results in client trust with 99% of the client satisfaction, as we have come across several projects and we have delivered with ultimate success. We also are always on support. We provide a premium 24/7 client assistance, ensuring that your research runs smoothly and deadlines are met and challenges are resolved without delay. Okay, so moving forward to introduce our team, we have Nadeem Khan, who is the CEO, and he has done his master's in bioinformatics from NAST University. His expertise are in NGS data analysis, multi-omics, and bioinformatics project development. Then we have Hazrat Maaz, who is the Chief Operating Officer. He is also doing his master from NAST University, and he has specialties in applied AI and machine learning, bioinformatics data analysis, web development, and IT. Then we have Munib Nasir, who is the Chief Technical Officer and a bioinformatician. He has also done his master from NAST University and also served as a research associate there as well. He is specialist in bioinformatics pipeline development, structural bioinformatics, and he is also proficient in providing consultancy services in the research development of several projects. Moving forward, this is Haseeb Manzoor again. I'm the Chief Scientific Officer of Omics Nexus. I have done my master's from NAST University, Pakistan, and right now I'm doing my PhD at University of Trento, Italy. And I'm specialist in metagenomics, machine learning-based biomarker discovery, and science communications. Okay, so talking about the events and the milestones that we have achieved so far. Initially, back in when the Omics Nexus was founded, it also have a 2-week crash course, which was on metagenomics analysis using Linux and R programming. After that, we have done the free webinar series where we had our first webinar on bioinformatics starter kit. It was a very a beginner-based webinar for all those people who have a little understanding of bioinformatics. So we got a lot of people who were involved in this webinar, and yeah, they got motivation to pursue their career in bioinformatics. Then we had from data to cure, AI and bioinformatics in modern healthcare webinar. It was also a part of the webinar series where we have a speaker named Aman Safir, who have an expertise in AI driven protein designs. Moving forward, we recently have a workshop series spanning around the January and February. This workshop series was basically consistent of three modules, which was on transcriptomics, then R for biologists, and machine learning for transcriptomics. And then we have a celebration of a big milestone that we have achieved, that we have upgraded or high performance computing systems, and now we can do any kind of bioinformatics analysis. I would say we have a RAM of 96 GB and a storage of 6 TB with 32 cores processor, and now we can do the all the specialized work in machine learning and simulations. And then last but not the least, our website is live. This is also a big achievement for us, as we recently have our webinar, which was also advertised on our website. And this is the reason why we wanted to have it as soon as possible, so we can engage you guys over our website. And I would like you all to please do go through across the website, and we'll welcome any kind of feedback that you have, so we can also improve it. Okay, so our upcoming event is regarding Nextflow. As most of you may have heard about the automation and pipelines. So Nextflow is a platform, and it is also, we are having a workshop upcoming to master the Nextflow. So we'll see you. So the tentative deadline, the schedule would be on the mid of May, but it is still tentative. We'll keep you updated once it finalized. Okay, so let me introduce you to the speaker of today's session. We have Munib Nasir, who holds an MS in bioinformatics. He's specializing in structural bioinformatics. He has a strong focus on computational workflows and automation. And under his cap, he has built and assisted in several tools and pipelines, including Metabolt, ARG Prism, and Ascent Preferentia, to accelerate therapeutic discovery and improve healthcare outcomes. So with this, I also welcome Munib Nasir for today's session. And yeah, just before I'll move on with the Munib Nasir slides, I would just like you all to please go through these QR codes, as we have social media platforms on like WhatsApp, YouTube, Facebook, Instagram, X, Twitter, LinkedIn, and we recently have our Omics Nexus website. So yeah, it is good to always explore, to stay informed and stay ahead. So now I'll over to you, Munib Nasir. So once again, welcome you for this session. Thank you.
Okay, thank you so much, Hasib. Thank you for the great introduction. And I hope I am audible clearly to all of you.
Yeah, you are.
Okay. Assalamu alaikum warahmatullah. This is Munib Nasir. And thank you, Hasib, for the great introduction. So today I will be conducting this session. It is basically a free webinar that we have been working on for a couple of months, that we thought that it should be presented to our clients and our customers, that GitHub is also a very important skill nowadays, especially after the ChatGPT and the AI boom, so that we have to manage and to host our code and our software somewhere else. So GitHub is a great platform, and so that we must have some basic knowledge about the GitHub. So I will formally start my presentation. So these are the contents that we will cover today, starting with the objectives of today's webinar, followed by the history or the origin of Git technology. We will also see that what is the difference between Git and the GitHub platform. And we will also cover some core concepts of the Git and the daily workflows that a common developer will usually encounter in his daily workflow or the development programs. I will also try to practically demonstrate some of those commands and core concepts, so that you can better understand. And then we will conclude our today's session. So the primary objective that we aim to achieve using this webinar is to achieve or teach the basics of how version control system works and the core difference between the Git technology and the GitHub. And the other objective is to master the practical commands of Git technology for the code handling, as well as learning how to manage the branches and the merging of the collaborative coding environments. So these are the two main objectives that we aim from this webinar. So coming to the history or the origin of Git, that how it was developed. Git was created in April 2005 by this young man, Linus Torvalds. So basically, as you may some people know him, he is also the brain behind the Linux kernel. Linux is the most popular platform or the operating system of all the times. So basically, this man named Linus, he faced a huge problem in managing thousands of branches and the thousands of versions of the Linux kernel. So at that time, there were some options, similar options like the Git technology that we see today. It was called, at that time, it was called BitKeeper. So that software was loosely based on the Git technology. So it basically tracks the unmodified changes and the different code branches and the problems and the bugs in the codes. So after that, he didn't like basically the that software which was called distributed version control system. So he reversed engineered that DVCS system, and in almost 10 days he proposed and he committed the Git software, and he made it open source to the Linux community. And later on, that open source technology was adopted by many other platforms which we know today, such as GitHub, GitLabs, or Bitbuckets. So these were some popular uh, origins of the Git. So coming to the difference between the Git technology and the GitHub itself. So Git is the main engine, you can say, behind the most of the version controlling systems, as we all know today. So Git is the tool or the engine, and it basically runs on our local machine or local computer, or you can say on your local laptop. So it is a command line or CLI based system. So it runs basically on the bash systems, and we execute the commands, and we modify or some track changes of our code using this command line system. The function is to track the history and creates version snapshots for that software or for that tool. And now, because Git is local CLI based software, so we also need some web-based systems so that we can host our code or softwares or tools on the web-based servers or cloud platforms. So here comes the GitHub. So GitHub is basically a web-based platform that basically hosts the repositories that enables the sharing and the visualization of the codes, tools, and the softwares. So basically, it is totally free. Anybody can log in and just create, as we create the accounts of Facebook or Twitter. So it's pretty much like same. So Git is basically used to control the softwares, and GitHub is a platform where we can host and share the codes with the other community and the other developers or teammates of our community. So the first, this is the page, and when we encounter a GitHub repository, so these are the first things that we can see. I have pointed out some of those key things that everyone should look. The first one is the main project folder. You can see here, where this shows the project name and the project repository name and the title of that repository, followed by the code. This section shows all the codes and the files that the Git and GitHub will track, and it will show to the community. So this is the main core of this whole repository. So it hosts the code on the website. And here, this section is the commit button. So it is basically a logbook, or you can say it is a history, just like the history of search engine. So it logs all the modifications and track all the changes that you have previously committed on the repository, on your software or the tool. And this is the front door. Basically, it is you can say the manual of this repository or the software. That it is basically a markdown or a text-based file that where developers describe the project, and they also describe the purpose and instruction, and some of them have also listed the manuals for contribution to that software or installation processes. So this is basically a text file or a README file, as we conventionally say it. And lastly, this is basically, this button shows the branches or the active universes, you can say, of this current repository. So these are the basic first contacts that a user will encounter when he or she will visit on a GitHub page. So to understand your personal arsenal of the local development, there are two main things that a user will need. The first one is the VS Code. A user must have a VS. Sorry, a user must have a Visual Studio Code. So Visual Studio, and the other one is the terminal or a Git bash. So you must have, if you want to work on GitHub, or you want to track your code and commit the history and commit the changes of your code. So there are two things that a user must have. One is a Visual Studio Code. So Visual Studio Code is basically a primary code editor, and it would be a central workspace for viewing, for visualizing, for editing and resolving the conflicts, and for merging the newer features in on your repository. And the GitHub, obviously, it is a command line tool. So Git will communicate with your repository via the Git instructions. We will see in the following slides. So these are basically two things that a user must have. So there is also a global ID card that the user will track, and it will show it on the GitHub or your repository. So these are just like we have the CNIC or the identity cards. So Git configures some global username, like we have our on emails, and the other one is your email. So these are the two basically main global IDs that the GitHub will use to track the changes and the person who have modified in your team. So this is the basically overall and the most common and the most usual workflow that a common developer will encounter. First of all, for example, let's say you want to work, you and your team have hosted software and on the GitHub, and you want to, and everybody in your team want to work on the specific feature of the project. So first of all, every user will download the repository using this simple command git clone, and then you will provide the whole link of the URL of your repository, which obviously will be on GitHub or GitLab. And this clone commands pulls or downloads the cloud repository to your local machine or your laptop or computer. Then you work on that repository, you add some features, you fix some bugs or some errors on your code, and then you have these changes are basically on your local machine. So if you want to push those changes or you want to update the code on your servers, you first have to check the status. You want to identify now that what changes I have made in my repository. So git status is the second command that is most commonly used. So it identifies the state of the files that are untracked. Untracked means that these files are new and are not and does not exist on your cloud repository. So git status will tell you that which files are untracked or new, and which files have been modified, and which files have been staged are ready, you can say, for the commit or the code to be pushed on the cloud repository of the GitHub. The third command is git add. So once you have made some changes on your code, now you want to prepare that code to be pushed on the cloud repository. So the git add dot command is to prepare the modified files to be committed on the cloud repository. Now this is the most important command, which is git commit -m and some message. So this quotation is basically a placeholder. You can, but you have to define any changes or you want to see or track the changes, that what changes I have made. So you will give it some message or some label so that you can refer it that what changes I have made. So this command git commit basically logs or takes a snapshot into the local machine and commits the changes in your repository. So finally, git push is the final command. So once you have committed the changes on your code, then you have to push the new local code up to your cloud, because all the changes that you have made in your on your laptop, these are on merely on your laptop, but you have to commit those changes and update the code on the cloud. So this command git push origin will push the changes onto your cloud repository. So starting from scratch to the cloud, so I have listed some 4 basic steps so that you can start or make a Git repository. First of all, if you are a Linux user, so this is a Linux command, mkdir. It's basically simply a command to make a new directory, or you can say a new folder. So you have made an ordinary directory on your laptop or your machine. Then how to make it a Git repository or a Git folder? So this command serves and creates a hidden .git folder. So this will initialize that this local or ordinary folder is now a Git repository. So So this command will create a Git tracking system, and it will track all the changes on your code. And once the changes that you have committed, now you want to add or connect your local directory to a destination server. So this command is basically acts like a bridge. So git remote means that it will bridge your local repository that is on your laptop and connects that local repository to your GitHub web server. So it will connect the local folder to a destination server. And finally, the get push command, as I have explained previously, that it connects the local server to the destination server, and it will push those changes to your cloud server. So now coming to the branching system. So let's suppose you and your team are working on a software, and you have some code or some scripts, and you create two teams. One team is to develop the feature A, and it will work totally on that feature, and the other team will try to develop that software further, and they will also see that if there are some bugs that are needed to be fixed on that code. So they what they will do, they will make the branches of that system. You can also say they will create the different alternative universe, but it is exactly the same exact replica of the original main code. So this was the initialization of the Git repository, and the one team was working on the feature one. So they created a branch from the original code, and they started working on the feature one. So now the main developers they developed the code further, and somehow they identified that there was a bug in our main repository. So they created a team B, or another team, that started trying to fix that bug in the repository. So now what will they will do? They created another branch that will totally work on and try to fix that bug in the main code. So once the team A have developed all the features, so these dots represents the changes or the commits, you can say. So each dot represents a specific change or a history of that code, that what changes I have made in the code. So the once the changes and the feature one is fully developed, so they will make a pull request to the developer team, and they will tell the developers that we have fully developed the feature one. Now please merge this feature one code into the main original repository code. So the maintainers team, or the core team of the repository that handles all the pull requests or all the branches, they will evaluate the code and the quality and security of the code. And once all the changes have been passed, so they will merge that change to the original code. Now at this commit, all the changes of feature one and all the changes of the main branch are also committed at this point. So this is basically the advantages of branching system, that multiple teams can work independently on the same software and the same environment, and they do not have to wait for the teammate that they need to pull the or merge the changes or fix the bugs in the code, and then the team A will continue to work afterwards. So the branching system allows a multi-universe of the same code, that all the teams can independently work on the same kind of code. So the branch system basically resolves the waiting for teammates to finish their codes. That slows down the development, and that was the core thing that's why Linus developed the Git technology. So the solution was to create an isolated parallel universes, which are also known as branches, to experiment safely without breaking the main code. So branches, how to create branches? So these are the basically say 4 simple commands that one has to create. You do not need to copy all the code on your local machine. You just have to execute this simple command, git branch. So this will show the active branches or the universes of the main original code. So to create a branch, you have to execute this command. So git checkout means it will check out that the new branch name and -b, and you will provide a new name for the branch. So this command will create and instantly you will instantly travel to the exact replica to a new branch. So git checkout main, once all the changes have been made to the branch A, so you can also move out and keep transiting across the different branches by this simple command git checkout main. So you can travel to different universes, or I can say you can travel to different branches, work on different branches with this git checkout command. So once all the changes have been made, now you can also delete that branch once the purpose is achieved. So once the feature has been fully developed, as I told you here, that the feature one team, or the team A, has developed the feature, and now they want to merge that feature into the main code. So what will they will do? They will create a pull request. It is a terminology that is used in the Git and the GitHub. So the team A will create a pull request to the main developers or the core maintainers of the team, that please review this code and merge it into the main repository of the code. So it is a three-step process. Basically, the first phase is the pull request creation. The branch code, or the feature that has been developed, is pushed to the GitHub request entry, and the senior developers will all review request changes and ensure that the code is safe and it does not break anything previously in our software or repository. So once the changes have been reviewed, they will approve that code, and the pull request is merged into the main repository, and the cloud and the main branch of the cloud has been updated. So now that the other developers, they also have to sync to their local repositories, because the local development that is on your laptop is totally independent from the changes that are being committed on the GitHub software. So GitHub, if there are changes some made on the cloud servers, so all the team members have to sync their their repositories. And how they will do? They will update their codes, because the local machines does not know that the cloud code was updated. So this command will allows the other teams to download and update their code to the latest version of the repository. So this is the main basically concept behind the pull request and the local syncing concept. So these are merely the terminologies that are used commonly in the Git and the GitHub code management. So let's say you have made some changes, or you have made some errors. So you can also Git also allows the user to undo some mistakes safely. So first of all, you need to there is a simple command called git log. It reveals the unique hash ID, or the commit ID, of the past commit in the code history. You can see the history and visualize what changes I have made previously in our code, and what errors are present. So to unstage or to uncommit a change that have been committed to the cloud repository, you can also use the git reset and the specific file. You can also specify a particular file name, so that all the changes will be reverted back to the original code if you have made some error. So these basically commands are very critical. So the user have to be very careful while using these code, executing these commands. So there is also another critical command, which is called git reset. So let's say if a branch, or if a team A have messed up some of the changes in the code, and all the features have break. So the user, the Git also allows to reset the whole timeline, or the whole history of the changes, and it will delete all the last commits, and the Git will safely keeps the type code in the editor. So this is also very crucial command. And this command is basically to hard reset. It will totally delete and completely wipe out the code from your editor, and you have to use it extremely cautiously. So before some parting remarks, I will try to demonstrate how a user can create a repository. So as previously identified in the slides, that how to make a Git repository. Let's say we will start by making a local repository. It is a common folder. So I will name it as dummy. So mkdir means make directory. It is basically a simple Linux command. So I will name my repository as dummy. So if we check here, ls means list. So I can see that the directory or the folder has been created. I will go to this folder, and I will initialize the Git repository. So in the slide, I have told you that Git init is simply to initialize the Git repository. So because this dummy folder was completely empty, so the Git tells me that it has initialized an empty Git repository at this specific path. So if I show you here, so you can see that .git command. So by this user executing this command, Git has created, and now the Git will track all the changes that I will make and all the files that I will create or delete in this folder. So I will start by making a new text file. So I will name it as test.txt. It is basically a text file. I will write it. This is a test. This is a text file. So now that we can see that test.txt file has been created. So if I open the Visual Studio Code, let me show you here. So we can see that the test.txt file has been created in the dummy directory. So this is the overall layout of our directory. So here we can track and see all the files that we are working on in this project. So this is the terminal basically, and we can also see this text file here. So terminal basically, so the VS Code basically simplifies all the editing and the modification and the visualization of those files. So with some of you might do not have any experience with the command line. So Visual Studio is basically a graphical user interface. So it allows the user to easily make changes in the file and update the codes or visualize anything. So you can, as you can see that the Git have tracked that this file is untracked. So it is basically a new file, and there are no changes that have been committed to the cloud servers. So all these changes are totally on my local machine or my laptop. So what I will do, I will try to create a commit using this. So Git status shows me that I am currently on the master branch, okay, which is conventionally named as master, and there are no commits that have been done on this repository. And it has also told us that this particular file is basically untracked, and now you have to commit that thing. So I will now commit stage that file by using git add test.txt. So it has now staged those files. I will
hello, sorry to interrupt. Yeah, but maybe there's some way that you can zoom it a bit, your terminal or maybe the text file.
Okay. Can you see now?
Yeah, thanks.
Okay. So now I have staged the changes by using the git add command. So this command has staged the file, and now I have checked the status. So this status shows that there is a new file that has been tracked, which is called test.txt. So now I will simply just commit, use the git -m. -m means that I can write some label or some message to this command. So this is a new file. See? So I will press enter, and it is basically I will enter my passphrase, which is a security feature. You can also configure it. So after the command has been executed, you can see that this file has been committed, and this is the specific hash ID of that command, that all the changes that you have made in this file. And it also says, because there was only one file that I have demonstrated here, so it says there is only one file have been changed and only one insertion. So let me tell you one thing, that Git technology is so intelligent that it tracks each and every word or even a single dot. So let's say I have I will remove this dot here. So you can say that when I save this command, so it instantly shows you that this file have been modified. So Git is basically that intelligent. So after that, now all the changes that I have committed here, these are simply on my local machine. So now I also need to create a GitHub hosting repository. So for that, we need to go to the our search engine. So let me just share my screen here. So this is basically the main overall terminal when you go to the GitHub website. So I will create a new repository by clicking on the new repository button. So it will ask you some changes. So here you have to provide the name of the repository, and I will name it exactly as dummy1. You can take whatever you want. So I will tell this as repository. So my repository name is dummy. So if you want to provide any description, you can give it here. This is our test or dummy repository. So it will show the description of the repository here. If you want to make it public, you can make it public, or your team is working on some crucial code, so you can also make it private. So for now, I will demonstrate it. I will leave it as public, and yeah, then I can simply click on this button. So it will now create a Git repository. So congratulations, we have now created a link that has been provided us, and it is unique, and no other repository can have this name. So I will simply, so GitHub also provided me some instructions. So for now, we have initialized our commit repository. We also have a TXT file. Here it has listed it as a readme.md file. So I have also committed my changes. So now I have to make a branch of my repository on my laptop, and then I will remember, we have to create a bridge between our local or laptop repository and the repository that is on the cloud GitHub servers. So by this command, it will create the bridge between both repositories. Then I will push all the changes that I have committed on my laptop to the repository that is on the GitHub servers. So for now, I will just copy this command and I will paste it here. So I have named my branch as master. So it will create the branch. So this command will show you all the branches that you have made. So -a means show the user all the branches. So for now, there is only one branch, which is called master branch. So now that what we have to do, we have to make a bridge between those repositories. So I will now run this command. So the command was git remote. Git remote means create a bridge between the two repositories. Add means add this branch to the commit side, and origin shows that this is the path that will be our upstream or cloud repository. So I will execute this now that the bridge has been developed between both of the repositories, and I will simply push my code or the changes on the repository. For now, if I show you here, if I reload this, it will simply does not show anything because there are no changes or no files that have been committed here. So this is totally different from the other one. So I will make changes and push here. So there was an error. Let me see here. So sorry. Yeah. There is no. Okay, let me show you. Oh, sorry. The problem was this have showed the main repository, but the main branch, but the original branch name was master. So that was my value. So I will change it to master. So then it will. So now all the changes that were on our local repository, all the changes have been pushed to the origin master, which are our cloud servers. So I will reload this page, and you can see that all the changes have been here. So that's how it is basically the most common workflow that a user will use. I can also show you one thing here. So me copy bash. I will copy this branch to the dummy folder. Now that I have copied another file from my home terminal, so this is basically a bash script. So it shows that these changes, because this file was not present and it is new, so it label it as the git label it as the untracked file. So now the we will commit the changes in sorry, first we have to stage the file. So this command will stage all the changes, and now we will commit the changes, and bash script, I will name it the message as bash script, and all the changes have been made to the master branch. So now what we have to do, we just have to push the changes to our origin master branch. So sorry, that was a typographic mistake. Origin. So now all the changes have been made to our cloud repository. So you can see that now there is no label, because both of the files are being tracked by the GitHub repository. And when we reload this session, so it will show us both of the files here. So let's say if you or your team has made some changes here, so you can also add a README file here on you made some changes on your cloud server. So this is dummy repo. I will make this change, and I will commit the changes here. So it has automatically provided me the git commit session, and when I commit the changes here, so it will provide us the label of the README file. So now these changes, so now we have committed that change on our cloud servers. So now how to pull those changes onto our local repository? I told you before, you have to pull the code or download the code from the upstream origin. So when you pull your code, you simply have to git pull, and it will pull all the changes from your code that has been and all the changes that has been committed on the cloud servers. So you can see that now you have also the README file. So this is the most common workflow. I hope I have demonstrated you well. So let me show you another thing. I want to show you that how complex thing can go. Recently I have been working on a project, and I will show you here that how a repository or a VS Code fully looks like when you are actively developing or working on some project. So the parting remarks are that version control system, GitHub, Git technology is also known as version control system, VCS system. It is more than a backup system, and it is not only to host your code on the GitHub servers. It is basically a complete framework, a revolutionary framework through which modern developers and the softwares communicate. They iterate their changes and codes and softwares, and they build the future together. So I have listed some of the systems that these are the cloud alternatives other than GitHub. GitHub is one of the most popular hosting servers that host your GitHub repositories. It is totally free. You can also create your Git repositories on the GitLab or the Bitbucket and the Deepwork. So these are basically all the same kind of services, but they have different features. But these are mostly for the advanced users. So now hold the keys to the engine and keep learning and keep exploring.
Okay, Munib, just a minute. I want to add something. If it is possible, so try to demonstrate that. For example, if a person want to explore a tool or install a tool using GitHub. For example, if a tool is uploaded on the GitHub and he want to install it, so how can it be?
Okay. So as per the request from Nadeem, I will demonstrate one more thing. I will show you how to read basically or go through some of the repositories. So in the initial slides of the today's session, I had pointed out some things that on the top left you will see the label of the repository. This is basically the username because my account is logged in here. So this is my username, and this is basically the tool. So it is this tool was basically a bioinformatics tool that was used that we have recently developed for the prioritization of the metagenomic variants. So it was for the bioinformation. So I made it very helpful, and we tried to make it thoroughly readable and easily usable for all the developers and the bioinformaticians that they want to use or install. So commonly, you have to see, you will see the repository or the tool name here. Then the code, original code files will be showed here. So these are basically some of the commits or the changes that I have incrementally developed. So you can see the labels or the changes here that these are the few last commits or the changes that I had made in the README files. And there was also some warnings or the depreciations. There was also some features that were actively developed in here. So this is basically the whole commit history, and we can also visit all the changes here if you want to revisit all the changes. So you can also see here. So I made just one digit. I just changed one digit here, and Git also tracked it that the version was changed here in that specific file, and it also shows the file name here, right? So this is basically this was a demonstration. Coming to the README file. So as I have explained earlier, that it was basically a tool for SNPs or for the prioritization of metagenomic variants. So commonly, the good developers they will show you some key things. First of all, the installation process. They will also show you the dependencies, that how on which tools this software is dependent upon. So before installing or before using this software, the user have to install these dependencies upon their systems. And then there will be also some usage that developers might have listed or described in their README files, that how to use their software. So because this tool was a command line based, this software was a command line tool. So we had listed here that how to provide the input, in which form you have to provide it, and then this is the screenshot basically that shows how the tools look. And this was basically a simple help command that I have embedded here. You can also use it as a Python script. And yeah, some developers they might have also provided you the specific file format, that how the file should be provided as an input. So we have clearly mentioned that this tool accepts both type of files like CSV file or the Excel sheet files as input. So this was basically the particular file format, that how to provide it. And some developers might have also provided the output or the expected output file. So we have also mentioned it here that the output file will have a CSV file or an Excel file, and it will have two main columns. It will have these columns, and we have also described it as which column belongs to that, which kind of descriptions. So there are some also configurations. So a good developer will make sure that the other user can easily understand without juggling around, and they can easily understand how to install that software, how it looks like, and how I have to provide it as an input. And especially a good developer will certainly provide the dependencies that we have tried to make it as simple as possible. So we tried to integrate all those dependencies. So as you can see here, you just have to run this command, pip install sn preferentia, and all these dependencies will automatically be installed. But if your code or your tool is on the initial stage, so you must provide the list of the dependencies that your tool is dependent upon, so that the user can manually install it, and the code or your tool will work fine with it. And we have also provided the login example, the examples, how to run it, how to test the development, and then most of the repositories will also show you the license. So basically, it was an open source tool. So we have provided it with the Apache license, and there was some pattern notice, and a user also must provide the credits and the citations if you have any publications of that tool or of that software. So these are basically, so the readme file is the most important one, because other users does not know that how to run your code. So readme file is very important, so that you can list all the things here, how to install it, how to run it, how to use it, how to provide the inputs, and how to get the expected output. So basically, this is the manual or the instruction files that comes with the code here. So I hope I have described it well, Nadeem. So if there are any question, please.
Okay, again, welcome back, guys. So yeah, just giving you a flashback, and at the same time moving forward, I'll again make an announcement that we have an upcoming on-site workshop that would be about the next flow. It would be basically to enhance your bioinformatics capabilities by joining our dedicated session on designing scalable, reproducible Nextflow pipelines. And yeah, do not miss to attend this exclusive opportunity. So we are we are almost finalizing our proposal with the National University of Sciences and Technology, NUST, and University of Management and Technology. Once we are finalized with them, and we will share the schedule with you guys about this series that would happen in both of these universities, hopefully. So yeah, until then, stay tuned. And yes, so if you're hesitant to step in the bioinformatics, basically, maybe you have complex biology fear, or you are afraid of coding, or you have fear of statistics, the Omics Nexus, it got your back, because we offer the training, workshops, and crash courses for you guys. We have certain services like project development and research services. We provide one-to-one mentorship and consultancy services as well. So yeah, just to stay updated, you have to scan this code, and you have already been added to the WhatsApp groups or WhatsApp channel and community. You can always write us, whether via the website, or in any social media platforms, or just email us, whatever the issue you have. Okay, so yeah, I think I'll bid you farewell for the questions and answer session. So thank you for joining us. If you have any questions, so please do ask, regardless of this session or anything regarding bioinformatics or whatever the confusion you have. So yeah, we have the people who would here to answer you. Thank you.